Hey everyone, this is Jason. Welcome to session 3 on our series Practical OSPF for Network Engineers. Today we're going to go through a lab. This is based on at least some of the topics that we've covered in the first 2 sessions. The items that we won't cover are going to be stub, total stub, not so stub type areas, the area types basically. And the reason is we'll do that lab after we've covered LSAs, probably in 2 videos for LSAs and then maybe 3 videos out for the next demo, right? So let's go ahead and dive right in. Here's the topology that we're going to be using, right? It's pretty simple. We've got 6 routers here. You can see that we do have an ASBR, so I did set that up, right? We're just not doing the area types. We have an ABR because we have 2 OSPF areas, area 0 and area 1, right? And then we have everything set up down below between R4, 5, and 6. I actually have a switch in between interconnecting them. So we also have the capability to look at doing a DR or designated router setup and election and how to influence that, right? So you can kind of see on my topology here, every router has a loopback 172.16 router number, right? So 172.16 1.1, 2.2, etc. The routes in the EIGRP domain fall into the 192.168 network. The area 0 routes, the WAN links are going to be in the 172.16 network, and the what I call the production networks are going to fall into the 10.1 network. And then for area 1, you can see I've got more 172.16s and then a 10.2. Let me talk a little bit about IP addressing. Now, this is a lab, so it doesn't matter how I address this so much. However, a couple of things. Number one is I always put in a loopback 0 to manage all my devices. I would recommend the same for you. We might do some like just general networking best practices in the future. If so, we'll kind of go through why we want a loopback 0 as our management interface on all the devices that would support it. And then I usually, if I have the ability, if I'm in a greenfield, for example, I like to use the 172.16.00/12 range from the RFC 1918 space for what I call my administrative or admin networks. These are networks that might be like loopback addresses, point-to-point links, management networks. It might be like a /26 or /27, kind of my odd networks that I might only route to if I was a network administrator. My general users and applications, they're not routing to one of these admin domains. They might route through it, like a point-to-point link, they'll route through it, but they don't route to it. Hopefully that makes sense. And then I'll usually subnet out of the 10.0.0.0/8 space, also from the RFC 1918. And I'll use that for what I call my production networks. These are items like my VLANs, right? So VLAN 2, VLAN 7, whatever. I'll usually route that in the 10 space. This is definitely not needed. It's a little bit wasteful, if I'm honest. It's a personal preference, and you're going to find a lot of what you're doing as a network engineer will come down to personal preference. My recommendation would be pick a strategy that works for you, understand why it works for you, what the strengths and what the weaknesses are of it, and then find a way to just explain it very simply to people. If they don't like it, if it doesn't fit their network, then maybe you don't go with that. If you're in a brownfield, which a lot of times I am when I'm working, I can't dictate to them necessarily what their IP addressing is. Depends on the nature of the project I'm working on, but a lot of times I can't. So here we're in a lab. I can do whatever I want. I also wanted a quick note on loopbacks. As you know, every router is going to have a loopback 0, but a lot of these routers will have additional loopbacks as well. Maybe loopback 1, loopback 2. I'm using those to emulate like VLANs on my lab. Obviously, you wouldn't do this in production unless you're trying to test out something. I do it here because it's a little easier than putting a switch behind all of these routers, configuring a VLAN, doing one-armed routing, all that kind of stuff. We could do that in a future demo if you're interested. Let me know. Also, if you're interested in the YAML files that I use to build this lab, please let me know. I can send them to you. I'm using Cisco Modeling Labs here. That's a free utility that you can also use. You can't get 6 instances. I believe you can only get 5 instances with the free version. You could still do an awful lot of labs with just 5 instances, right? You could just cut out R6 down here and still have a DR election, and just to go through the motions, it might not look right, but it would totally work, right? So a lot of options there. Here you can see are the 6 routers, right? And you will find that my IP addressing is done. However, I don't have my routing set up for OSPF yet. No neighbors, right? I did, however, pre-configure the EIGRP. Right? And indeed, if I come over to R2, I believe I should have some EIGRP routes. Yes. You see, I have 3 of those 192.168 routes. By the end of this, I should be able to ping those 3 networks, right? Which again are really just loopback interfaces. If I come over here to R1, which is my EIGRP speaker, you'll see I just have a total of 4 loopbacks, right? Let's take a look at how EIGRP, this isn't an EIGRP demo, of course, but right. So you can kind of see I've set up my EIGRP this way. What I wanted to point out is, again, with loopbacks, one of the things you're going to find that I always do is in every routing process, whether it's OSPF, EIGRP, or BGP, those are the only 3 you're likely to use on a common basis, right? I always set the router ID, and I set it to be my loopback 0 interface. However, I find this is a point of confusion for a lot of people. Just because you use it as a router ID doesn't mean that the router needs to advertise it. It's using it to anchor the routing process to an interface on that device, whether that interface is participating in the routing protocol itself. So you'll see that my router ID is set up to be this loopback 0 interface. However, that loopback 0 interface is not participating currently in EIGRP, right? So it's just something to be aware of. So let's come in and take a look here. Let's configure OSPF over here. Now, the first thing is when we're configuring OSPF, this number 100, that's called the PID or the process ID, process identifier. And in OSPF, that PID could be unique per router. You could make router 2, router OSPF 2, router 3, router OSPF 3, router 4, OSPF 4, etc. Of course, we would never recommend that. Pick a process ID for your autonomous system and stick with it for the most part, unless I don't know if we'll get into some of these advanced scenarios. There could be times to run a different process, like 2 processes on one router, in which case I've got 2 autonomous systems effectively that are both OSPF and redistribute between the 2. The only reason you would do something like that is kind of advanced redistribution scenarios or route filter scenarios. Several sessions from now, we'll go through route filtering, and there are some challenges in EIGRP when it comes to route filtering. It does support it, of course, but there's some challenges. So In our case, we're just going to use OSPF 100 on all the routers. This is in stark contrast to EIGRP, where that number represents the EIGRP autonomous system, and it does need to match on all the routers, or the EIGRP process name if you're doing named EIGRP. Okay. So the first thing we're going to do is, we mentioned this in one of the first sessions, we're going to set our reference bandwidth. Okay. So I'm setting it to be 100 gigabits per second, right? Why do we do that? Just as a reminder, the reference bandwidth in OSPF defaults to 100 meg, which is pretty outdated, right? That means a 100 meg link, a 1 gig link, a 10 gig link, they all have an OSPF cost of 1. You can't go below 1. So they all look the same. If I had all three of those links, OSPF would just load balance equally between them because it sees 100 meg, 1 gig, and 10 gig all as the same speed. The reference bandwidth all matches, right? The metric equals. So I'm going to set it to 100 gig. Now, of course, this means if I have routed links above 100 gig, it's going to default to 100 gig. They'll have a cost, again, equal to 1. However, I feel that if you have routed links at above 100 gig, you're in a pretty special environment, and you can kind of figure that out. You can go above 100 gig. I don't know what the limitation is, to be honest. I'd have to look that up. Remember, this is practical network engineering. I wouldn't memorize a number like that, but I'm going to say it's probably somewhere in the terabits. So anyway, we're going to do this consistently across all of our routers. Okay, so I set the reference bandwidth. I'm going to set the router ID. And then I'm going to start adding in my interfaces. So I like to use the do command. So do show IP interface brief so that they're all right in front of me. And then I can start adding my network interfaces. Let's come back and look at the topology. We'll see that R2 for OSPF is only connected to area 0. Now it's an ASBR because it's also connected to an EIGRP domain. It's not an ASBR yet because we haven't redistributed those routes, but when we do, it'll become an ASBR. But the only area that it's connected to is OSPF area 0, right? So I know that my area then will always be area 0. So I'm going to add in 172.16.0.0. Okay. So this is covering this G01 interface, right? You could put in 172.16.0.1 and make it a quad 0 on the inverse mask. I recommend you get used to doing these masks, though, and just putting in specifically what you want. You could definitely do it the other way. It works either way. I just think this is a good way to do our skill building, right? And I always recommend you do one network statement per interface for the most part. Don't do things like redistribute connected or something like that. That can lead to a lot of operational issues because if later on I add an interface and I don't want it in the routing process, unless you had the foresight to create like a prefix list and a route map or something like that, you may find that it automatically hits the OSPF process, and that might not be what you want. So I always like to do one network statement per network on the router. Let's add our loopback. And that is a /32, so we can use a quad 0. Okay. And then I have two, I have a loopback 1 and a loopback 2. These are always going to be /24s, just so you know. That's just the way I've configured those interfaces. So let's add those. And now we'll add the second one. Okay. So we have everything entered in. And now if we do a show run and we go to pipe it to the section of OSPF, sure enough. So we have set our router ID, we've set our auto cost reference bandwidth, and we've added our network statements. I'm just going to fast forward over here to router 3, and I'm just going to configure router 3's area 0 interfaces for now. Okay. Router ID. And now I'm going to start doing my network statements. Here's my loopback 0. I'll put that in area 0. It has one link, one point-to-point link in area 0. And you'll note it has a loopback 1 and a loopback 2 as well. And you'll see that those are in area 0 because they're coming out of that 10.1 SuperNet, right? So let's add those in. Okay, now if we take a look here, show run, pipe dissection, OSPF. Sure enough, that looks pretty compatible with R2. So let's see if we have an adjacency. Show IP OSPF neighbor. This is a great command. So not only do we have an adjacency, it tells us how long we have left on the dead timer. But look at this. It says state is full, meaning I have a full adjacency. I'm exchanging not just LSAs, but routes are going back and forth. It tells me my interface, what the address is of the peer, what the neighbor ID is. Note that the address is 0.2. We knew that. But the neighbor ID is indeed that loopback. That's what happens when I set the router ID, right? However, under state, besides full, it says BDR, backup designated router. So if I come over here and do the same command, the other router should be a designated router. IP OSPF neighbor. And sure enough, we see the same thing, right? So we talked about this in one of the earlier sessions. We don't really want DR BDRs, or there's no need, perhaps I should say, to have a DR BDR on a routed point-to-point link, right? So we can overrule this by changing the network type on the interface. Let's also look and see if we're getting routes. Show IP route OSPF. Indeed, we are receiving routes. Remember those loopbacks, 10.1.1.0? Except look, even though I entered it as a /24, it's coming across as a /32. Why is that, right? Well, if we come over here, let's take a look, show IP OSPF interface. If I take a look at that loopback 1 interface, for example, you can see that it says the address is indeed 10.1.1.1/24. It's in area 0, right? However, notice it says network type is loopback. This is a special OSPF network type. And we're going to change our loopback 1 and 2 interfaces on these routers to instead be point-to-point. Okay. And then you'll see over here my G01 interface, right? It's set up as a broadcast. We're also going to change that to point-to-point. And that's going to get rid of our DR BDR status. So if I come over here, Okay. And now if I come back to R3, let's take a look at those routes first. Oh, it's probably show IP OSPF neighbor. I think the network type has to probably match is why we're doing this. Welcome to a live lab, right? If we come in and we do interface G00 IP OSPF network. We have definitely now set where we're no longer DR BDR. Oh, here they are. It just took a second. And now you'll see that those 10.1 routes are coming through with their actual net mask, right? Likewise, if I come over here, show IP route OSPF. So I have the same problem over here because I haven't gone through and changed those loopback 1 and 2 interfaces to be 24s, or sorry, to be network type of point-to-point. Let's just enter that. And now if I come back here, there we go. And now it's updated. One thing worth noting, and if we do a deep dive on EIGRP, which we might well do later this year, you'll see one of the big differences between these two protocols is EIGRP, the distance vector protocol, is going to be significantly faster. You see how I have to up arrow a few times. The neighbor process is so much slower in OSPF, and the updates thereby kind of end up trickling in a little. I wouldn't call it a slow protocol. It's not like, say, BGP if you don't do things to improve BGP's convergence, but it is slow compared to EIGRP. EIGRP is probably the fastest routing protocol out there. So that being said, we've seen what the basic OSPF setup looks like. What I'm going to do now is pause the recording and I'll go configure OSPF, but I won't do any more advanced setting than what we've already seen, right? Changing network types, entering networks, changing auto cost reference bandwidth, and setting a router ID. Okay, I have my basic OSPF set now. And I've fully configured R3, 4, 5, and 6. R2 is previously more or less fully configured. The only thing we haven't done on R2 is introduce the EIGRP routes into OSPF. We'll do that at the end. If I come into R6 and I do a show IP route OSPF, we now see quite a few routes in here. You'll note that all those loopbacks are coming in as 24s, exactly as expected, right? Now, one thing I'm going to point out, and it's a bit of a teaser for when we do LSAs, right? There's two types of routes. All of the routes are O's, but some of the routes are also OIA. So it could be just a native O route or an OIA route. If we go up to our secret decoder ring up here, an O just means it's a native OSPF route. And IA means inter-area route, so it's between two areas. So these IA routes are coming from our ABR, right? That should be a little bit obvious when we think about what inter-area means. It means between two areas. The only way I connect the two areas is to have an ABR. So we'll talk about that more when we get into the LSA sections. Let's take a look at our neighbors. So we can see that I have a DR and a DR other, right? If I come over here, same thing, show IP OSPF neighbor, right? Here it's saying that, hey, R4 is my DR, R6 is my BDR. This should show something similar. R6 is my BDR, I think it was. Show IP OSPF neighbor. Yep. So R6 is my BDR, and R5 is DR other. That just means it's participating in the designated router process. However, it was not elected. This is working out because R4 is our DR, and that makes sense. To get anywhere interesting from area 1, we need to hit our ABR, which is R3. The only router in area 1 that has a connection to the ABR is R4. So indeed, we want R4 to be our designated router. But let's make sure that that never changes, that we don't run into a situation where an election might happen or a process reload might happen and the DR resets. Like, so for example, if I come in here and I do, if I clear the IP OSPF process, I don't know if I can force this, but we'll try. If I come down to R6 now, you'll see it's starting to reform. So R5 became the BDR. I mean, X start. Now I'm in full, but you'll see that R4 became my DR other. This isn't desirable, right? So how could we keep that from happening? Well, we talked about this, I think, in the second session, which is we're going to set we're going to basically stack the cards in R4's favor when it comes to that DR election. We do this with the IP OSPF priority command. Now, if you have two routers that we're connecting up to your ABR, you could set one to be the DR, one to be the BDR, right? And then you'll need to figure out, based on your topology, based on your company's needs, whether you even want the other routers participating in the DR process, right? Let's say, for example, in our topology, right? I'm going to say we want R4 to be the DR, and I really don't want a BDR. Why? Because no one else connects to the ABR. And so I'm just going to set R4 to be the DR, and I'm going to take R5 and R6 out of the mix. So I'll set the priority here to 10. And on R5 and R6, I'll set the priority to 0. OSPF priority 0. Okay. Now, you might think, okay, so everything should be working. Let's see what it looks like if I do my neighbor command. Well, indeed, now you see that R4 has become the full DR, right? And you'll see that R5, I don't have a full state with R5 anymore. Now I'm in a two-way DR other. And I should see something similar on R5. R5 should see R6 as a two-way DR other and R4 as the DR. And indeed, what does that mean? That means that R6 and R5 are aware of each other, but they're not doing full neighbor adjacencies. This makes sense. That's exactly what we get in a DR-BDR. Remember, the whole point of having a DR is everyone becomes adjacent to it, and it multicasts out the updates, right? And again, we'll talk about this a little bit when we get to LSAs. There's a specific LSA that deals with this called a LSA type 2. That's for the next session. So this is now all set. The only thing we're missing at this point would be our EIGRP routes, right? So I should be able to ping, for example, 10.1.1.1. That's a loop back all the way back on R2. And sure enough, I can, right? I should be able to ping that even if I source from one of my local interfaces. So 10.2.5.1, for example. Sure enough, no problem. Why is that? Because if I come to R2, it will have full routes as well. You can see before, this is an older command, but this is back when I only had R2 and R3 configured for area 0. So I had no inter-area routes, only intra-area routes. But now you can see I have all of these. Makes sense, right? So now we're going to configure redistribution to go from EIGRP into OSPF. This will convert R2 from an area router into an ASBR, an autonomous system boundary router, right? So let's go ahead and do that. Now, the way I'm going to do redistribution today is not how I want you doing redistribution. We're going to have a whole session towards the end of this series on route filtering and redistribution and best practices. Today, I'm doing this just to make it kind of quick and easy. You can probably tell it's a little difficult for me to type and think and talk all three at the same time. So I'm just going to take the easy path on this one. I'll go into OSPF and I will redistribute EIGRP and we will add in subnets. Now, you could do things like setting your metric and metric type. Again, we're going to get into that later in a future session, right? Normally, I would say use at a minimum a route map, and within the route map, use a prefix list. Again, we'll get into that. For right now, this is what we'll do. If I come back to R6, for example, now you can see I have some external routes, 192.168, 1.0, 2.0, 3.0. Of course, ping would not work at this point. Why? Because we haven't done mutual redistribution. We've only redistributed it in one direction. Let's come back first and clean up EIGRP a little bit. Let's just add in my loopback 0 interface as well so I can ping everything. I'll go into the EIGRP process. I'll do a network statement. If I come back to R6 and I do this, I should now also see a 172.16.1.1. And indeed I do. This E2 means it's an external route. It's OSPF, but it was originated external to the autonomous system, right? So if you see something like E1 or E2, you know that you have an ASBR somewhere. If I come into R2 now I can come in and redistribute from OSPF into EIGRP. Okay. Now in EIGRP, we have something called the seed metric, and the seed metric in EIGRP is true for most, if not all, distance vector routing protocols, is infinite, meaning I'll introduce the route, but it's never reachable. It has a metric of infinity. Can't really get to something that's infinitely far away. So I'm going to set a metric here. And when I set a metric in EIGRP, just so you know, I understand that really the only two K values that are meaningful are the first two, bandwidth and delay. I just, as a best practice, I put them all in. So Now, if I come over here, I should see OSPF routes in my EIGRP table. And sure enough, see all these external routes? And now, if I try to ping, for example, 172.16.1.1, that's loopback 0 all the way back on R1, sure enough, I can do it, right? Or I could ping one of those 192.168s. Right. So let's just recap real quick, right? What did we configure here today? We configured an external routing process. We redistributed it mutually between EIGRP and OSPF. We set up multi-area OSPF. We have area 0, area 1. We changed our OSPF network types to be appropriate to the type of configuration, right? So that, R2 to R3, R3 to R4 are going to be point-to-points. R4 to R5 and R6 is going to be a broadcast network, which is defaults to. I didn't have to change that part. And down on that broadcast network, I set the priority to ensure that I could pick up the appropriate designated router. And then I dropped R5 and R6 from the DR election process entirely, right? So that's quite a bit. I think we're good there. I want to thank you for joining me today. And the next session, I think we'll go ahead and start diving into LSAs. I don't know, but I'll predict that's probably going to be broken into a couple of different sessions, right? LSAs is a little bit deeper. We won't cover every single LSA type, but we'll cover most of them. This is the first time I've done a live demo on this channel. I would really appreciate any feedback you have. You can always reach me at jbomar@la-networks.com, or you can leave a comment in the YouTube channel itself. I'll do my best to get back to those. I hope you're getting something out of this series. It's been a lot of fun for me. Hope you're enjoying it as well. Definitely some learning curves. I'll try to get better as time goes on. Thank you so much for your time today.
Need help? Call our cybersecurity team and book a consultation with us today.